All right. Hello, everybody, and welcome to today's pro webinar from Nexa 3D. My name is Sean, and today we're we're going to answer the question, hopefully, is desktop manufacturing a reality in 2023? So before I introduce the squad that we have here, which is a pretty good one, I think we've got like between us maybe 50 years of additive experience. I'm going to tell you a little bit about Nexa 3D if you're not familiar. So Nexa 3D, we're a manufacturer of 3D printers ranging from desktop to industrial. And that's a combination of resin technologies like you see on the left here, as well as our new powder solution in the QLS. Well, we're probably going to primarily focus on desktop because that is the topic after all. And we like to say we're building a sustainable digital supply chain through additive manufacturing. So that is a priority for us, which I think is pretty relevant for today's topic. All of our products are designed and manufactured in Ventura, California, where Harsha is right now, I believe. And they're used by a diverse group of customers with a common need for speed. So everything from consumer products to government, automotive, motorsports, and actually Bruce's company is right there at the end, Applied Rapid Technologies, service providers. So we will definitely talk about them. So yeah, let's go ahead and intro everybody. So first off, we have Harsha. Harsha is our head of applications engineering for Nexa 3D. How's it going, Harsha?
Hello, guys.
Cool. Then we've got, yeah, good. Sorry, didn't mean to cut you off there.
It's all good.
Then we've got Vlad Goodsman. He is the founder of Liquid Sound Technologies. Vlad, how you doing, man?
All right, guys. How y'all?
Good. Vlad's flying from making his way from Vegas to Georgia right now. So I think he's running on a pot of coffee.
Landed in Toronto. You behind.
Okay, there we go. And then we've got Bruce Lemaster, the founder of Applied Rapid Technologies. How you doing, Bruce?
Very good. Hello, everyone.
Awesome. Cool. Well, before I forget, I want to run a little poll and ask everybody who they are, or rather what their experience is with 3D printing. So I just threw that up on the screen. If you have a second, go ahead and answer that. Which best describes you? I'm interested in getting my first 3D printer. I already have 3D printer, but could use an upgrade or an addition. I already have all the 3D printers I need, or I'm just curious about 3D printing tech, but don't have an application for it. And I'll give about 3 more seconds for everybody to fill that out. 3, 2, 1. All right, cool. All right, so it looks like we'll throw that up on the screen. Looks like most of you either already have a 3D printer and could use an upgrade or an addition, or you're just curious about 3D printing tech, but don't really have an application for it yet. So that's cool. Hopefully we can answer some of the questions and help people determine if this is something that could be useful for them. All right, today's agenda, really quickly, we're going to, over the next hour, we're going to ask the question, why local on-demand manufacturing? Like, why is that important? Why are people talking about that? Then we're going to give 3 reasons today's ultra-fast desktop 3D printers are changing the game, and kind of how that's directly impacting this local on-demand manufacturing. Then we'll kind of ask another question. Is desktop manufacturing already happening? Wink, wink. It might be, based on some of these guys who we have on here. And that was a terrible wink. And then we're going to give some tips for getting started with desktop manufacturing. And then lastly, if we have time and if we have questions, we will get into a Q&A. So do you see that Q&A button on your screen or the chat button? Either one will work. Don't forget to use that throughout to ask your questions, and then we'll get to some of those at the end. And while you have that chat button up, go ahead and say hi, where you're from. Like to see where people are from in these things. So, all right, shall we get into it? I think so. All right, so let's start off. Why local on-demand manufacturing? So this is everybody's talking about the supply chain today, right? I mean, it's I've clearly oversimplified it for many of you, but I want to talk about how, this is kind of, I think this kind of shows how like a new product goes through manufacturing at a very high level. So you start out step one, prototyping, in that product design process. So you're kind of doing that maybe more in-house or more locally, and 3D printers are often used for this anyway. After that, once you've kind of identified that prototype is in fact going to work, now it's time to go into manufacturing. So you create the tooling often, and that's kind of in the traditional overseas model. Then you get kind of this small sample batch order to validate that the tooling works and that the parts are coming out correctly and they're working, before ordering maybe a larger stocking order, and then building out your inventory so that you're ready to deliver to customers, right? So that's, again, oversimplified version. Now, with this comes several issues. So I'm probably going to ask Vlad and Bruce to maybe help me with some of these. So maybe Vlad, if you could start out here. Long lead times. So what kind of lead times do overseas? Like what have you seen in your experience?
So typically in the in R&D mode, in development mode, especially on a small batch of product that you need to test, you looking anywhere from 4 to 8 weeks to get a small sample on production, and that's the times that were probably 2 years ago. Now it's more like 4 months to 6 months, especially on manufacturing. Again, if you're just starting out and you need a small batch. So with the 3-4 different revisions, you're looking 9 months to a year. And that's been our typical kind of to benchmark for any overseas manufacturing.
Yeah. Okay. So long lead times, no doubt, 9 months to a year. I mean, talk about you need a significant amount of planning and secondly, high minimum order quantities. So Vlad, I'm going to let you speak to this one too, because I know this is something as like a small business owner that you've talked about.
Yeah.
Like
So
what's a minimum quantity look like? So
for us, as you see behind me, there is a guitar with bridge pin bowls. They're kind of they're actually made out of XCE now, but previously we made them in brass. And for us to get a good or reasonable price break on these parts, our minimum order was 10,000 sets, and that was well over $300,000, which when you do not have a good understanding of what you're going to be able to sell and how fast, that's the big pill to swallow right away.
For sure. All right, Bruce, tell me about supply chain disruptions.
Very numerous right now, as most people probably know. When COVID first started, our phones were ringing off the hook. All the major medical supply companies, protective gear, personal protective equipment companies were trying to reshore to get product out there quickly. And, any small disruption in supply chain can have a devastating effect on your manufacturing process. So, we're working with a lot of local companies, especially here in Virginia. We've got a really good state-sponsored manufacturing program where they're putting a lot of grant money out there to do reshoring, they call it, trying to get production here in the state of Virginia, vice overseas. And we're able to source these things locally now, as opposed to waiting for them to come in from China.
Awesome. Upfront costs, obviously they're going to be significant costs with these long lead times, high quantity orders. And I believe this is something Vlad has mentioned to me, as in the several hundreds of thousands of dollars to order this kind of stocking inventory, right? And that's at discounted rates. So you're getting those high quantities so you can get the cheapest cost per part. But that upfront overhead cost when you're waiting 9 months for the products to arrive is just capital that's idly sitting that you can't use, right?
That's correct.
Yeah. So especially for, small businesses, or in this time, when interest rates are high and capital is not readily available, that is tough to swallow, to have money just out there. And then lastly, this new product development to manufacturing transition pains. And I think this kind of, this sums up like all of the above, right? But talking about going from that prototyping stage, maybe you're using 3D printing, and then you need to switch to like a different technology, to molding, to an injection mold, to tooling it up. And, I think there just inherently come pains with that, of figuring out, how that kind of 3D print or whatever translates to that mold. Or you have to do the test of the mold. And then if the mold doesn't work out, like how much do those molds cost? Like tens of thousands of dollars, right? So if the tolerances are off, it could get expensive quickly, I think is the point there. So those are kind of I'm sure there are more issues we could talk about, but I think those are the 5 that probably cover what we want to say here. So on that note, I'm going to pass it around the room and ask you guys, what do you think of when you think of local on-demand manufacturing? And Bruce, I'll go ahead and start with you. Like, your business does this, obviously. So what does that mean to you?
For us, it means being able to take something that normally we would machine or do cast urethanes for. About half of our business is cast urethane work. So we're at a point now where we're trying to pull production out of the urethane business and just print it. And that's the printing is working great for 100 to 1,000 pieces. We can locally do that right here on site and turn that around in a matter of hours or days, depending on the size of the part. Just have a project right now that we just quoted 1,000 pieces. I can fit 72 of those parts on a platform at one time. It's 3 hours and 20 minutes of print time. So I can cycle one machine. I can cycle 3 prints a day. So in 5 days, I'll have the 1,000 parts. And they were currently looking at FDM to do those, and they were looking at months worth of production on the FDM machine. So just any opportunity we have to pull something in that would normally go either overseas or to a longer lead manufacturing process, machining, CNC, whatever it is. But we can do that now with the printers, and it's just working
Awesome.
out really well.
Sweet. And what about you, Vlad? What's your take on this?
For us, especially being on the innovative side of developing with guitars or other, I have 2 hats, so we do a lot of music, and we still do a little bit of consulting for poultry processing equipment manufacturing. So to be able to produce a prototype within days or reverse engineer a part within weeks that is printed in metal, obviously not with Nexa yet, but to have a prototype or that part in hand within days, really, or any changes, which anybody who does R&D know that there are so many revisions before you come up with what it is that you want to settle with. It is just a blast. Be able to switch between different materials, if you would, or just make revisions and as you go test them. That's for us has been a night and day difference and speed up the process of where we spent almost a year developing our bridge pin bowl system, where now I can add any revision I want to it. I can change up things in so many different ways and then test them. And I don't have to wait weeks. It's actually days now, so it's crazy.
That's awesome. And then Harsha, I'll ask you as well. What I mean, you work with a ton of our customers and prospective customers.
Yeah, absolutely. I basically echo what Bruce and Lad already mentioned, to be honest, because it's about saving time and cost for what it means to have local demanding manufacturing, as well as having material options on your site. So you're not waiting on one particular material. You have a selection of materials that you can go with, as well as having the freedom to make design changes in a minute or so. You don't need to wait months to make a design change and then wait for the part to arrive. You can make that design change the same day and then get something printed or manufacture your parts and do your testing right away. So that way you're actually saving time as well as a lot of cost cutting.
For sure. That's awesome. Yeah, I agree. I think I always think of the digital inventory aspect of not having to have like rooms full of spare parts, but the fantasy of having your inventory be on a computer or in a server in the cloud, and then having your printer with all your materials right there. So it's like taking up a much smaller footprint and just, especially like spare parts or jigs and fixtures. I think that's probably maybe more of a relevant case, but there are so many possibilities, I think, with local on-demand manufacturing. So, all right, with that, I think we'll move on to the next section. So let's talk about 3 reasons today's ultra-fast desktop 3D printers are changing the game, right? So this is a desktop 3D printer. I think probably a lot of people on here are actually familiar with this. It's an Ultimaker company that's been around for a long time. It's an FDM type 3D printer, and this is not real time, right? This is a time lapse. And to be honest, we all use time lapses because 3D printers are not that fast, like inherently and traditionally, they've not been that fast. So what looks like it's printing in a few seconds is actually the real speed that it's printing in, right? So, for something that's the full build volume can take quite a bit of time. And in that Ultimaker case, that first video, that was a 22-hour print. And it was using a pretty simple material, right? PLA. So that is, if you used a desktop 3D printer before, you're probably familiar with PLA. It is probably the most common material hands down for FDM or FFF printers because it's simple to print with. It's pretty thermally stable. It doesn't warp a lot. It doesn't shrink a lot, basically, in when it's heating and cooling. So I won't say like there are dozens of different thermoplastics that are available for 3D printers, but in reality, like most of them are pretty difficult to print with if you don't control like a ton of variables and like such as heating the chamber and stuff like that. So, you kind of have to take, the technology that's been around and yes, there are certainly people who have been using this to manufacture, but it's kind of outdated at this point, to be honest. And that's kind of where we come in as a company next to 3D. So that is pretty much our number one priority is bringing speed into the game. And that so if you look at these two printers here, on the right side, you've got the NXE 400 Pro. So that is our industrial 3D printer. I believe, Bruce, you've got a bunch of these actually in your facility, right?
I have 15 of them. I've got 6 in the showroom.
Wow. Okay. So yeah, a lot of production going on with those. And that was kind of one of our first technologies. So I think unlike a lot of other companies that have gone from desktop and moved up the chain, we've actually taken this up chain high speed technology that we call LSPC and brought it to the desktop with our Zip. So Zip came out last year. So that's our newest 3D printer. And it has all of that same technology, but packed into a smaller footprint and a smaller build volume too, right? You can't do as big prints or as much maybe throughput as you could with the 400 Pro, but it's lightning fast. To give you guys an idea of kind of a production build that I think our printers do really well are these 3-way connector builds. We have these all over the place. We always have them at trade shows. In this case, this 3-way connector build, it fills up the whole build volume of the Zip, which is about a 4.8 liter build volume. It's using XABS, which is actually one of our slowest materials, but also it's a pretty high performance material. You see it in the name, ABS. So it's a pretty durable, robust material for production parts. It's not, unlike PLA, which, to be fair, I've printed a ton in PLA. There's nothing wrong with it other than the fact that it's just thermally unstable. It has a low heat deflection temp. It's pretty brittle. But it's good for kind of prototypes. But if you want real production parts, you need something a little bit more robust. That's what you have here. And this is showing 168 parts in about just under 9 hours. That's 3 minutes and 7 seconds per part. If you really wanted to speed that up and you wanted something more along the lines of what we saw with PLA, like just a modeling material, or maybe something that you want in, high quantities, but doesn't need to be as robust, you could print this in our X45 material in about an hour. So, high speeds are definitely possible with this technology. And I'll show you how that actually stacks up against the two other main technologies. So here we've got LSPC on the left, RTEC in the dark blue versus SLA versus FDM, right? So, and specifically the Form 3 Plus and the Ultimaker S3, because those are just two of the most well-known professional desktop printers out there. If you were printing one part, like pretty similar to what you just saw, actually, I think this print would be a little bit bigger than what you saw. If you're printing one of those, about 43 minutes on the Zip, about 72 minutes on the Ultimaker, and 114 minutes on the Form. So not a huge difference. Now, if you scale that up to printing 27 parts, like we're talking about with scaling up production, that translates into 7 times longer of a print on the Form 3 on an SLA printer, or 33 times longer on an FDM printer, using similar materials. I think this is benched using the fastest materials for all 3 and the same like layer heights and everything is apples to apples across the board. So just gives you an idea for the capabilities to scaling up and running these kinds of production runs, and what we mean when we say ultra fast 3D printers. And how does that work? So there are these different technologies, and on the left in the red graphics, you've got FDM and SLA, and both of those work by basically drawing out with a single tip, almost like you're drawing it with a pencil, each layer. So in FDM, you've got the extruder drawing. In SLA, you've got a single laser point that's drawing. It's got to draw every aspect of this. So the more prints you get on a plate, the bigger, more of the surface area you're using of the build plate, the more that line has to move around, right? Now, if you look to the right, you see DLP and our LSPC tech, and those are working on a different principle. They're more projector style. So they're projecting light, like a UV light or close to a UV light in our case. And it's curing the resin rather than using a laser. It's curing it, but it's curing it the entire layer at one time, right? So it gets to flood the whole layer with light. And in the case of our fastest resins, that can print an entire layer in like 2 seconds, right? So incredibly fast. Imagine how long an extruder has to move around to like print an entire part for the whole build plate. It's just not possible to match the speeds of curing it all at one time. So that's kind of the reason for the disparity. Our technology, the LSPC, takes it a step further. We've got some proprietary aspects built in that allow us to be actually faster than similar MSLA and DLP technologies, making it, maybe either one of the top 2 fastest resin printers or the top, depending on who you ask, but very fast. Okay, that was a lot about speed. Take a second here. The second thing, the second reason that these printers are game changers is because of the materials. So Nexa 3D has over 20 materials. So modeling materials as well as a bunch of engineering materials in the resin library, and that now also we've got a few in the powder library as well with our QLS platform. In fact, you can see them all listed here. So there's quite a variety with a whole range of different properties. But if you think about, like, if you're familiar with the industry at all, that like the thermoplastics have been around kind of longer than these resins. So resins are kind of catching up now. And we recorded a recorded webinar on this 2 days ago. My coworker Lewis did this, and he talks about how, this idea that thermoplastics, extruding a plastic, that technology has been around for 50 plus years. So all different kinds of thermoplastics already exist, and just the process of extruding them, there's not a lot that goes into like figuring out how that works. Now, photo cured resins, the technology wasn't really there. The materials weren't really there yet. So it's taken longer for those to catch up. But now that they have, you're seeing companies like BASF, like Henkel, Loctite, both of which are our partners, and other companies too, big material companies that are diving in and really changing the game with materials like XCE. So this is one material that I know Vlad and Bruce are both familiar with. I believe both of the case studies that you guys are going to show that are kind of featured right here use these materials, correct? Is that right, guys?
Yes.
Okay, so that's like an example of a material that maybe a resin that, I don't know, Harsha, maybe what that compound is. That this C, I can't remember. I know I've looked it up before.
I think it stands for cyanidethylene. It's a more rigid material with high flexural properties.
Okay.
So it can withstand up to like very high pressure points. In case of Vlad, where we did multiple tests, I think his requirement was 40 lb, so 40 pounds of pressure on those little guitar pieces. And it's very, very robust, and then lasts a long time.
Yeah. Okay. Yeah, exactly. So that's a great example of a performance engineering production material that you can print now with a in resin. And I think most people are, I mean, I know when I came to Nexa 3D less than a year ago, I was coming from, more of the filament side. I was not familiar with all of these different resins that now exist. So I think that's the case for a lot of people. Like, you think of resin printers as like printing these detailed, delicate prototypes, and like you can certainly do that. Like we certainly have super high detail model materials, but these performance resins, I think, are what interest a lot of people now, and especially people like Vlad and Bruce who are using this for production. So, and by the way, we're going to go into both of your stories in depth, Vlad and Bruce. So stick around. We're not skipping over them completely. A couple other materials I want to call out: the X Peak that we have. So that's a high temp material, resin. It's meant to simulate a peak, and Pepsi happens to use that in their blow molds. They put these inserts in, which allows them to speed up their time in producing molds. They don't have to machine these complicated mold inserts anymore. They can kind of throw this 3D printed case, or I guess insert, into a machined outer shell, and then very quickly change out the shapes that the bottles are going to be blow molded in. And they can get like 15, I know it says 10,000 on here. They can get, actually, the last time I spoke to them, they were doing over 15,000 shots per blow mold. So pretty robust material that's able to withstand those very high pressures, very high temperatures within molds like this. And then one other material that I like a lot, again, coming from that FTM world, I'm more familiar with like the Peaks and the ABSs, and I think all of these materials that I just mentioned, correct me if I'm wrong, Harsha, that are Henkel, or at least the last two are Henkel, and kind of a smart way to brand these resins that stack up nicely with their thermoplastic analogs that people are familiar with, the XABS specifically. So anyway, XABS is an example of case study that should be coming out here in the next week or two, but a little sneak peek. Actually, it's already a story that people have told, but Alstom, rolling stock manufacturer based out of France. But they provide rail cars globally, and they use our printers with this XABS material for replacement parts. So parts that no longer exist, that are no longer being manufactured. And I know Bruce has something to say about that, because that's exactly what I believe in your case, your story was about, that we showcase in a second. So again, just a nice engineering material. And then the third one, which is inherent, I think, with any desktop 3D printer, is just accessibility. Having these things at your fingertips, whether it's on your desk or set up in some kind of rack or along a table with a bunch of printers. They're in your facility, or they're in Bruce's case, they're in Bruce's facility around the block from your facility. So they're local, they're accessible. They can, you can run a prototype, you can run a production run, you can print one part, you can print 60 parts at once. So you've got kind of that ability to directly control it. And you're not waiting 9 months for something that's happening overseas and trying to coordinate all the logistics to get your parts to you. And we've put in, I think our engineers have done a nice job of adding a few touches, such as a smart resin cartridge that refills the vat as it's printing. The software as well, a lot of thought goes into that, making it easy to use. I threw a little quote in here just to pat us on the back a little bit, but I kind of got to do that for my job. And this was actually from a new 3D printing industry report, which just came out like last week. They did a full report on Zip, and they actually reviewed Nexa X2, and they said the use of this software is flawless. Print process is convenient for a user who's making its first steps into 3D printing. So I thought that was really nice. I think this, I've personally used this for a little while now. I know all of you guys have used it as well. It's, I think for a newish company that hasn't been around for a decade, it's pretty powerful stuff, and it's relatively easy to use as well. So I think that covers everything. Yeah, those are the three things that are making ultra fast 3D printers game changers. So now I've been talking for a long time, so I'm gonna take this opportunity to pass the mic. Is desktop manufacturing happening already? I think you guys know where this is going. I'm gonna pass it over to Bruce first. And Bruce, I want you to talk about this case study that we've showcased for a few months now with one of your customers.
Sure thing. This is a good example of the kind of projects that we get a lot into. This is an obsolescence case where this lift that you see, the big orange 4-wheel drive thing there, on a lot of construction sites, these systems are 20 years old and they're no longer being supported by the original manufacturer. Spare parts are becoming hard to get. So we have a local customer that specializes in rebuilding and servicing these machines. So they came to us and asked if we could replicate the parts that they're having trouble getting. And in this case, on the left-hand side, you see a picture of the two joysticks there. There's a rubber boot on the bottom. There's the joystick handle. It's a 2-piece unit. There's a rubber cap on the top, and there's a button inside the handle. So we are producing all of those pieces. Currently, the bottom rubber bellow is a cast urethane part. The handles we've been doing as cast urethanes, but we're currently working to transition that into printing. But the button inside the handle and the rubber cap that goes on top of the handle is something that we're currently printing. So the center pictures there, you can see a tray of the buttons on the bottom, and the top there is a tray of the X-Flex rubber-like caps that go on the top of that handle. So the button sits right underneath that rubber cap. The person using the joystick can press that rubber cap and the button underneath it and get the machine to do what they want it to do. So our customer needs roughly 50 to 100 of these per month. We can print the buttons in batches of, I think it's 72. I forget the numbers now. 1, 2, 3, 4, 5, 6, 7, 8, 3, 6, 9, 10. So of 80 or so on that platform right there. So that platform takes, originally we had it at 40 minutes. At the IMTS show, we were displaying this, and I think we got that down to 18 minutes at the show with some optimization of the parameters. So in less than a half hour, or let's say, I could print 2 of these in 40 minutes, give or take. That would give me a full month's worth of production. And the rubber buttons caps on the top there, same kind of thing. We can print those in an hour and a half. So within a couple, 3-4 hours, I can have a month's worth of production. And this is just a steady stream of parts that we're doing for this customer. And it's solving a problem of not being able to get these parts again. There was no CAD data originally, so we had to do some reverse engineering to get that process started. But now we have that data and we can just print these. And if they want to make any tweaks to it along the way, we can adjust it for the next build. And, it's kind of seamless operation. We print and make adjustments as necessary.
2 questions from my end on that. One, the rubber you used was the X-Flex material, right? So that's
Yes.
a printed rubber-like material.
Yes.
Cool. And then the other one was guess-
XCE Black, the bottom buttons there are the XCE.
the XC, right? So X Flex and XC. So you're a combination of different materials for all going into this assembly. And then my other question was the customer. Had you gotten feedback from your customer on this? Because I mean, I think that's one of the other concerns is putting something in the cab of a vehicle that's going to be exposed to the elements out, probably sitting outside on a construction site on hot days and such.
Yeah, the feedback has been great. We've had parts out in the field now for close to 6 months, 5 months, 6 months timeframe, and no issues reported at this point. The customer's happy, and he keeps coming back every month to order more parts. So for me, that's the best endorsement we've had so far.
Awesome. Yeah. Cool. All right. And then I'm gonna switch gears and pass over to you, Vlad. So if you could tell us a little bit about how you're using the Zip with your in-house manufacturing.
Well, just as a lot of people in 3D or familiar with 3D, we started with just using FDMs for quick prototyping, which was not quick. But then moved slowly to semi-production items. Obviously, couldn't get anything very nice looking, especially with regards to threads and or threaded components. As you see on the left of your screen, it's our take on Bridge Doctor, where guitarists need a repair. So we made this thing in XCE. Well, actually did it in X Pro as well, and it held up. And the what it's doing, it's when the guitar caves in a little bit, the top over the years, especially on the older guitars or very thin top guitars, you need to reinforce it to where the bridge stays stable. So we were able to make it in again in the materials I just mentioned, and it's twice as light and close to twice as strong as the previous just wooden piece, very hunky, very ugly. And the installation of the Bridge Doctor 2.0 can be done with using traditional screws or using our bridge pin bolts. The items you see on the right, it's you see the brass bridge pin bolts that we have manufactured in Taiwan on a 5X machine. So that was again very expensive to pass on to the customer. So wasn't able to swallow the $325,000 pill. We invested in the Zip. Harsha helped us with the case study on what material we need to use for the longevity. And as you see the guitar behind me and the pins that are inside the guitar, they've been there since I want to say March of last year. March is something like that. No, March, April is when we initially printed them. Had to make some changes on the on a modeling side to accommodate the printing. At the same time, gotten access to unlimited possibilities and unlimited basically changes, especially if there is a rolling change or we want to do a design on top or anything. It's just rolling change, and it's done literally within the next print you're making. The double row of the pins were 44 minutes, I think, plus the curing time, and then some post-processing, and they're ready to go.
Awesome. So yeah, it's and And Vlad, you were manufacturing in Taiwan. We talked about the 9-month lead time, that I don't know how many $100,000s for a minimum order quantity. You said that $10,000 order was to get the bulk discount, which was one of the cheapest per part costs you could find. And by printing these on demand now, I think you said you're saving about 90% on that per part cost.
So the cost of material for us to print is, I believe, 90 cents with the XE, and Harsha might even have the original study we've done. And just the cost of material, previously, for me to get the price break on our brass pins, it was an order for, let's say, 10,000 sets of 6, so that's significant. And the price were close to $3.25 per bolt. So it's a significant reduction in cost.
Awesome. Yeah. And I like that. I mean, then you have the flexibility of the on demand. You don't have this huge inventory. I know you've said if you want to make a design modification or come out with a V2 or a 2.0, you need to sell through. And maybe you still have 4,000 on it, and that you have to sell through of the old model before you move to that, as opposed to the 3D printed ones where you can just switch over and you're making the new design.
Yeah, and it makes it a lot more exciting for customers to try, because they're not spending $60 per set. They're spending just a little more than what they pay for a latte at Starbucks. So it's very exciting.
The old Starbucks analogy that it always plays well. All right, cool. Well, thank you guys for sharing those stories. All right, so we got 12 minutes left, so I'm gonna have Harsha give you guys some tips for if you're looking to get started with desktop manufacturing.
Yeah, so yeah, usually guys, whenever we talk to prospects or any new resellers who wants to come on board with us, we try to understand exactly what kind of quantities and their application requirements. So my team will basically ask you a series of questions, try to identify your material needs, whether we have it inside on our Nexa platform, or we also have a open platform where you can bring in a third-party resin. So we will help you, or we will guide you to find the right material for your particular application. Once that is done, then we will focus on, figuring out the cost and whatnot is applicable for your application, and then whether we can actually provide you with a feasible solution for the problem that you're trying to solve. In some cases, our technology might not match the requirements, and we will tell you right away, so we are not wasting anyone's time. And then we got to make sure that you have the personnel to operate the machines, and then you have the knowledge base to know how to deal with our software, as well as figure out how to conduct or like go through the cleaning and washing workflows in order to get the best out of our machines. And then once all of that is done, once we came up with a good solution to you, we actually want to continue that relationship, the partnership moving forward, just so that in case you decide to try something completely different application, we want to be able to provide you with that constant support moving forward.
Sweet.
So,
awesome. Yeah, and I think on that fifth note too, whether you're working directly with Harsha and his team, or Bruce is now, I know you guys are a reseller as well as a service provider. So we've got partners all over the world who you can work directly with. And, I know Bruce and Applied Rapid Technologies is a really good option for that as well. So Bruce, I think you have 25 years with Applied Rapid plus 27, and talk about somebody who's been using resin 3D printing since the mid 90s, early 90s. So
Exactly.
lot of knowledge there, and Bruce and his team as well. All right, actually, before I forget, I do want also Harsha to talk a little bit about Next Factory. I think you probably already covered some of these points, but what is Next Factory?
Yeah, so Next Factory is our in-house print farm, or the factory that we do all our benchmarking efforts. So we have a group of 3 engineers, myself included, and 3 other technicians who help out with all of our print services here. So we have a fleet of NXE machines, our large printers, as well as a fleet of Zip, our new desktop printers. So usually, I think I touched upon some of these points already, but at the beginning of a call, you probably will get in touch with one of our sales representatives, and then we will get involved, where we will try to identify the material needs. And I mentioned again, we have 26 validated materials already on our Nexa platform, but we are also a open platform where you can bring in your own third-party resin to print on our machines. And you're not on your own if you choose to do so, because our team will help you validate these new materials on our platforms, just so that you would have a starting point to get up and running. Once that is done, then we will do your benchmarking. We will give you a simulation showing how long your parts will take, what the cost breakdown is like, and whether certain materials are compatible on our machines, and how feasible it is. Once that step is done, then we would send you out the parts. We would sit down with you, get some feedback from you, just so that we understand where we're doing good versus what we are lacking, and like what kind of changes or modifications that we need to do. So in case of Vlad, I think we had 3 or 4 different chats, iterations that we're trying to figure out. So we made modifications on our side, and then you made some design changes to your part, just so that we can find that perfect fit for your particular application. Once both sides are happy, then we move on to installation, where you will get your printer, and then that's again another challenge where we need to make sure all the stuff that we did in-house, we need to transfer that knowledge to our customers. So that's where the training and knowledge share becomes important. So our team and the customer support group are readily available to provide that. And I mentioned again, and that's not the end point. We are available throughout afterwards to provide with any future application supports as needed for our customers.
Awesome. All right. And with that, we've got time for a Q&A. Yes. So a ton of questions have already been written in, but if you guys have more questions, feel free to go ahead and drop those into the Q&A and chat right now. Let's see. I will start out with one about the speed specifically. I don't know if Harsha, you can speak to this, like what kinds of speeds do you see with the NXE 400 or the Zip? I know different numbers have been, is there a printing rate, or like a height per minute or whatever?
Yeah, I
Or
think
per
we
hour?
usually, yeah, with regards to speed, I think we refer to them as centimeters per minute. So I think our fastest material is around 0.7 centimeters per minute, our ceramic material. This is very much material dependent question. So usually most of the prototyping materials or rigid materials can print faster, whereas your industry grade high performance material will take a little bit long. For example, ABS material or like our PEEK-like material will take a lot longer, because they have the chemical formula that you need to cure longer to get those material properties out.
Awesome. Will light engine stitching be something in the near future so build plate size can increase with the VAT printing technology? I think that Harsha, I don't know if you know the answer to that. It might be talking about DLP, which is kind of limited to a 4K chip. So in which case people kind of fake that with side-by-side chips. But I think with the screens that we use, there are continued higher resolutions being developed because LCD technology is so prevalently used. Do you think I'm reading that right? Or
I think so. In our case, like with our technology, MSLA, you're working with a light array. So doesn't matter how big your screen is, as long as you have the light engine to match that LCD. So you're getting consistent illumination all across the board. The only limitation on our side is the resolution of the LCD screen itself, which is, I think you mentioned 4K. So we can go up to 7K, 8K to get that high resolution, moving into the future.
For sure. Let's see. I saw there was a question for Bruce. Looks like Bruce was you pretty actively and Vlad both in there answering in the chat. But I'm gonna let you answer this one on the screen on camera if people didn't see that, asking about some of the specific parts that you've seen in terms of durability in the field again, because I think that's a pretty cool one to talk about. And they were talking about the wall lift specifically.
Yeah, so as I noted earlier, we've only had those out in the field for 5 to 6 months. No failures to date that we're aware of. I don't foresee any. We beat them up, bang them around here just to do some internal testing with them. They seem to work out well. So the XCE black buttons, they're covered by the rubber boots, so they're not really going to see any UV light. Don't know if that would make a difference or not, but so far the X Flex black has not shown degradation from sunlight exposure. I'm sure, like any rubber, over a long period of time, that will start to dry out and need to be replaced. But it's certainly something that's easily done in the field right now.
And on that same note, Vlad, what kind of tortured testing did you guys do? I know you talked a little bit about like how long those bridge pins have been tensioned, and remind me how much force is on those things.
So typically with the guitar strings, you have a forward pull for the neck of I believe it's 200 pounds, 120 minimum, depending on the string tension. They're light, medium, and heavy strings. But we have done something additionally with those bridge pin bolts, horizontal of the pin. We have inserted a 1.1 millimeter hole to insert a string that would pull on the bridge pin bolt backwards, and that was to assist a friend of mine with his innovation for guitar. It's a reverse tension guitars. He's using we were helping him with again with his invention. So we're pulling backwards on 2 pins, 40 pounds each. So there's 2 pins in the middle of the bridge. Again, there is not that much material, maybe 2 millimeters thick. Again, those bridge pin bolts, if anybody familiar with guitars, those pins are very, very tiny. So we end up having only 4.5 millimeter stem threaded, and then just a head to cover the string bolt inside, maybe 2.5, 3 millimeter at most in some places, and we tune guitars a lot higher than they need to be just to check the durability. Again, it has not been tested on the stage with people banging on a guitar, but you don't really bang on acoustic guitars. So we're pretty confident that that they do hold up. And on another tension strength test, I would insert my hand underneath the strings, and instead of having string pulling on the bridge pin bolt to see if it breaks, I tried to do a gravity of the guitar weight to pull on the pins upward. So it's a lot of pressure being applied in the area that we didn't anticipate to test, but it holds up. It does what it does. And with our invention, it holds a brass plate underneath the bridge on top of that. So it's been I've been very satisfied. We might try a couple of different materials yet later, but it's a good success point so far.
Awesome. Cool. And I think with that, we do have a few other questions that I don't think we're really gonna have time to answer, but we'll try to get to you folks maybe in a follow-up email. If you do want to talk to somebody at Nexa 3D, or if you just want to request a sample, you can actually, that's up on the screen now, the XROOK. We actually ship those out, I think, in our X Model 15 model material, which is kind of this gray material that you see, this little this model here I have printed. Also in our X Flex material, which is kind of like the material that Bruce was talking about. So get one of those, talk to a sales rep or talk to the folks over at Applied Rapid Technologies as well. Great source of knowledge. And figure out if this is a good option for you, if we have the material, or if even there are other things you need to consider. But I want to thank everybody for joining. Thank you guys. Thanks Vlad, Harsha, and Bruce for imparting your wisdom. It was truly enlightening from my standpoint. So thank you guys.
Sure thing.
It was a pleasure, guys. Thank you.
Cool. All right. And with that, we will say goodbye. So until next time, happy printing and have a great weekend. Bye, everyone.